All right, so as we look at 3-2, we are going to use our knowledge of exponential and logistic graphs, and we're going to actually solve problems related to those. So this is just a smattering of problems. Now, I will not make you memorize these formulas. I think that's ridiculous. So I'll give them to you. You don't have to worry about memorizing them, but you do have to know what the parts of the formulas are. So the first one that we're going to look at is exponential population. So population can either grow or decrease. This is really no different than if we had y equals a times b to the x. That's your general exponential graph. You see how 1 plus r is our b because it's raised to a variable exponent, and p sub 0 is our a, our initial value. So it's just a little bit more complicated with 1 plus r. So what do you think p sub 0 means? With population. Initial population. So your initial population will go there. And then as you look at what the question is asking you, tell whether the population model is an exponential growth function or a decay function. So we can have decay in population, that just means it's being reduced. And find the constant percent rate of growth or decay. That's what R is. Constant percent rate of growth or decay. If you're looking at specifically R, if R is positive, it will be growth. If R is negative, it will be decay. That's only if it's written in the 1 plus R form. If you look at what I have down here, oh, and then what do you think T is? And you got the total T, time. Now, time can be in, time can be in hours, seconds, days, weeks, months, years. Typically the population is going to be in years, but not always. So then look what I have down here. P of T, that's your Y, is 857 times 857,391 times 1.0057 to the T. Isn't this, here's my Y equals A times B to the X. That you can really see now. I like to determine whether it's growth or decay just based upon looking at that. Is that a growth or a decay model? Why is it growth? Because the 1.0057 is greater than 1. Remember that? If the base is greater than 1, it's growth. If the base is less than 1, as this one is, it's decay. But if I'm looking at the 1 plus R, that's where you have to determine positive versus negative. So there is a difference depending on what form it is. So make sure you know what form you have and how to determine that. All right, so they want to know what, all they want to know is the constant percent rate of growth or decay. Isn't that R? Are they just asking for R? So all I care about for the first part of the question is this part right here, the 1 plus R. That's the part that's raised to that variable exponent. Isn't that this part right here? So I can just pull that out of the equation, and I can say, okay, 1 plus R should exactly equal 1.0057. Because the 1 plus R is the same as the 1.057, or 0.57. And the 1 plus R. How do you solve for R? Subtract 1. So we're going to subtract 1 from both sides, and you get R equals. Now, write yourself a huge note here. Guess the calculator. These questions will be on the calculator portion of your test.
that's so cool.
Oh yeah, that one. Jeepers, that's really hard to subtract 1 from, isn't it? What'd you get? 0057. What year?
Yesterday's got compound.
Many parts of it, yes. Because I could have done nearly everything in yesterday's essential life calculator. Okay, but note that it wants the percent rate. We want the percent rate. Is that in a percent form? No. How do you change something to a percent? Multiply it by 100, or you move your decimal point 2 places to the right. So I move my decimal 2 places to the right, so that equals, as I'm throwing my pens, 0.57%, and it's growth. And it's growth because one of 2 reasons. My R is positive, or the 1.0057 is greater than 1. Show low. Who moves to show low? People are leaving show low. Yes, you have who lives in show low? Old people. Are they old? No. Wealthy? Okay, that's why they have a second home. Yes. You have to do what? No, not for this particular one. We'll use it in a minute. Alright, so then look at part B. Again, I only care about, if I'm just finding the constant rate of growth of decay, I just care about looking at that part of the equation that they gave us. So I'm going to take 1 plus R and set it equal to 0.9921. Solve for R, you're going to subtract 1. So R ends up being you get a negative 0.0079. And again, that's not its percent form. So convert it to its percent, move the decimal 2 places to the right, or multiply by 100. And that equals, and notice I'm going to drop the negative off, 0.79% decay. When I mention the word decay, it's understood that that's a negative percent of growth. If we're growing negatively, it must be decaying. So that's not so bad, right? There's several questions just like that. There are no questions on your homework that you can't find on these notes. So have your notes handy as you're doing your homework. Then example 2, we're going to actually find the exponential function. So they're going to give us information to plug into here to actually write our own function. So determine the exponential function with an initial value of 11. So initial value of 11 is what value here? Is it P of T? Is it P sub 0? Is it R? Or is it T? P of 0. This is P of 0. And then increasing, very important that it says increasing at a rate of 9%. What's the 9% going to represent? R. And don't I want to convert this to its non-percent form? So how to go backwards? So when I go backwards from a percent to its number, I go backwards going to the left, and I move my decimal to the left. I have to add a 0 as a placeholder. So I actually get 0.09, and notice that my decimal point is to the right of 9 if you can't see it. Is this a positive or a negative when it's increasing? So this means it's positive R. So my R, bless you, my R is positive. And then per year. So let's go ahead and write our formula. P sub T is equal to, instead of P sub 0, I'm putting in 11 times 1, and then because my R is positive, I'm putting in plus 0.09. And parentheses, I'm raising that to a T. I'm perfectly happy with that as an answer, but I don't know if Math Excel will take it. So the other form that you could have is you actually can combine the 1 and the 0.09. So I've got 11 times, you could still leave it in parentheses. If you add those together, you get 1.09 raised to T. This is probably what Math Excel wants. But you could try the other one and see if they'll take it. So then B, the only difference with B is they use the word decreasing. So the initial value of 5 is again what? B sub 0. And then this time we're decreasing. And we have our rate of 3.2%. Move the decimal to the left 2 places. Add a 0 as a placeholder. So is my R going to be positive or negative? Because it's decreasing, we have a negative. So our R is negative 0.032. So when I put it into P of T, I get my 5, parentheses, 1, but minus this time, 0.032, raise the T. So again, I'm happy with that answer. It doesn't bother me. Math Excel may want you to actually subtract that. And so we get 968 when we subtract. So 5 times 9.968. Raise the T. Issues with that first formula. Alright. So then example 3 now uses radioactive decay. So any problem that you see the word half-life is going to be using this formula. Notice that the base here is 1/2 and it's raised to a variable exponent. If the base is 1/2, is this growth or decay? Decay. Half-life is generally used with radioactive material. It can be used with other things. You're going to mostly see it in your textbook with radioactive material. It's just looking at a particular amount of something, and over time it decreases in value. And at some point it has a half-life. And that just means that half of the product is gone after a certain amount of time. So the EPA loves half-lives with businesses that give off toxins into the air, so or air, water, ground, wherever it might be. And so they'll use a lot of these different types of formulas. This just happens to be one of them. So what do you think Y sub 0 is? Initial amount of whatever the stuff is. Our 1/2 is our base. What do you think the H is here? It's being divided into time, so what do you think the H is? Half-life. That's why they call it H, yeah. So H is your half-life, and so T is your time. Now, if your time and your half-life are not the same units of measure, so if you have time in years and your half-life in weeks, you need to make a conversion. They both have to be the same units of measure. So if that occurs, you need to make that adjustment. All right, so part A, we have 10 grams of radioactive material. Where does that go? That's your initial amount, so that's your Y sub 0. Then we have a half-life of 25 years. What's that? That's your H. And then find the amount of radioactive material. So find the amount of radioactive material. What do you think that's going to be? Left. Base. Because that base is 1/2. Y. That's what we're finding, right? So that's your Y. And then after 80 years, what's the 80 years? Time. So that's all we have to do is just plug it into that formula. So I'm going to take Y equals Y sub 0 is 10 grams. I suggest you use the units of measure as given. Times 1/2 raised. My T is 80 years. And then my half-life is 25 years. Don't the years cancel out? We have 80 over 25. Really, at this point, you're using your calculator. There's no need to reduce the 80 25ths. because you're just going to use your calc. So be careful when you plug it in. You've got 10 parentheses, 1 divided by 2 end parentheses, raised to, if you have the older calculators, where it shows a caret instead of a little box, you have to use parentheses when you do the 80 divided by 25. Otherwise, it'll raise it to the 80, but divide the entire thing by 25, so you get the wrong answer. So just make sure that you double check your calculator at home with the answer that we get here and make sure you're using the calculator correctly. So I don't have to on mine, so I've got 80 divided by 25. And then enter. If we're not told where to round, what do we do? So we're going to round to 2 decimal places. I am going to start to mark you off for rounding incorrectly. What do we round to? If I'm rounding to the first 8. Look next door, you have an 8 next door that's 5 or higher, so you bump this one up to a higher number, so it's 1.09. And that's in grams. So therefore, there is about, as we're estimating, 1.09 grams of radioactive material left after 80 years. That's not so hard. You have to figure out where to put things in the formula, how to put it in the calculator. Alright, the last one is modeling a rumor. It uses logistics functions. And again, you'll be given the formula. For this particular situation, this is the formula. The formula changes based upon the situation. So this is modeling a rumor. So Horizon High School has 2,400 students. Note that 2,400 is here, because the maximum number of students that can hear the rumor would be 2,400 students. So it has that horizontal asymptote that the function cannot cross. Bob, Harold, Ted, and Alice started a rumor, which spreads logistically so that, here's your formula, models the number of students who have heard the rumor by the end of day T. So T is in days. What would be your other horizontal asymptote? You got y equals 2,400, what's the other one? 0. Y equals 0, because we can't have negative students, right? Hearing the rumor, so that makes sense. So first question, how many students have heard the rumor by the end of day 0? So day 0, we're going to replace that here. Where does that go? T. That is T. What am I trying to find? How many students have heard the rumor? What is that in the formula? That's your S of T. That's your total amount, right? S of T is your total amount of Y. So we're trying to find S of T. We're going to take our formula, S of, I'm plugging in 0 for T, and that equals 2,400 divided by 1 plus 39 times E to the negative 0.9 times T, which is 0. I don't even have to use a calculator for this one. Let's see if I can zoom in on this. Then you have to use a calculator. What's negative 0.9 times 0? 0. What's e to the 0? 1. So I have 2,400 over 1 plus 39 times, and I got a 1 when I took e to the 0. Then what's 39 times 1? 39 plus 1, 40. So I've got 2,400 divided by 40. Don't the zeros at the end cancel. And so how many times does 240, how many times is it divisible by 4? 60. So what does that 60 represent? Students. So therefore, students heard the rumor. By the end of day 0. Whoops, you can't see that. What does that mean to you? Day 0? That's the initial day, right? Like even before the day began, 60 students had already heard the rumor. How many kids started the rumor? 4. You would think the answer would be 4. This just implies that those 4 kids might have started the rumor, but it spread quite rapidly before you even had a chance to let it out of your mouth. So maybe when they spread the rumor to 60 kids at the very outset, those 4 kids. So, the part B. Part B is harder. And here's why. Look what they gave you. How long will it take? What is that? That is time. How long will it take? That is your T for time. For 500 students to hear the rumor. 500 students is what? How long will it take for 500 students to hear the rumor? That's your S of T, isn't it? That's the whole amount. We're going to replace all of S of T with 500. So you get 500 equals all of this, 2,400 divided by 1 plus 39 e to the negative 0.9 t. We have to find t. Well, t is an unknown in an exponent. You've not been taught how to do this yet. The only way to do this algebraically is through log functions, and we haven't gotten there yet. So there's a process. It's really not that bad. You use your calculator. So step 1 of the process. You are going to put into y sub 1 equals, you go to your calculator, you're going to go to y equals, and the first y equals, you're going to put for 500. That's going to create a horizontal line going through the y-axis at 500. And then you're going to put into your calculator into y sub 2, the next one down. You're going to put the right side, but be really careful how you input it. You're going to put 2,400 divided by, make sure that denominator is in parentheses, 1 plus 39e, the negative 0.9 t. Now some of you may have to have a second set of parentheses here for the exponent if you're using an older calculator. You're going to put 2 sets of parentheses. So you're going to put those into their separate spots. So here's my calc. Going to y equals, and there's those 2 formulas. There's the 500, and here's the 2,400. 1 plus 39 times e to the negative 0.9x. So mine doesn't need extra parentheses. Yours might if you have a caret. So then, take this away for a moment. So then if I hit graph, notice what happens. Oh, we have 2 different graphs. So before, okay, that's what it looks like. But your next step, step 2, you need to find the intersection. Find the intersection of the 2 lines. So one's horizontal, one is not. It's logistical. And so this is what it looks like. What's the problem? Y equals 500 is way up there, isn't it? So even if I zoom out, waiting. Oh, nope, still don't see it. So probably what's my best bet? Go to your window, right? So go to window and adjust your Y scale. I want to squish that down. Do I need a y value that's negative? No, because I know my horizontal asymptotes are y equals 0 and y equals 2,400, right? So I'm going to put this at 0. And my max, I know that I'm looking for a line that goes across the y-axis at 500. So I only need to get up to 500, but I'm going to go a little over, so I'm going to go to 550. So then what should my scale be? I don't want to go by ones. Mr. Hayes, we've talked about the whole policy. I go by 25s. You go by 10s. 10s might be too much. But there we go. So there's the line. And here comes our curve. So can I see the intersection? So how do you find the intersection in calculus? Second calc, intersect, which is 5. So it's first going to be flashing, and mine happens to be flashing on the horizontal line, which is fine. That's my first line, so hit enter. And then it's flashing all the way down here. I tend to like it a little closer to the intersection, so I'm going to get my cursor. So now it's up here flashing. Hit enter, and then enter again, and it should be right there at the intersection you're looking for. And sure enough, my y is 500. But that's not what I want. I want the x value at which they intersect. So what is that rounded correctly? 2.59, because we bumped the 8 up to a 9. So it's approximately x, or in this case t. Did I mention that we used x and not t? Because if you use t, your calculator won't recognize it correctly because in the x-axis is x. So we replace that with x. So it's approximately 2.59. Now, you cannot say, therefore, after 2.59 days, 500 students have heard the rumor. Are they going to stop the day at exactly 2.59 and figure out who's heard the rumor? No. Days come in whole units. So if you go to your table, second table, if you put in the 0, look at the rightmost column, that's where the 60, the original column, comes from. After day 1, we now have 142 students who have heard the rumor, and then a portion of the students haven't heard part of the rumor. And then after day 2, 322 students heard the rumor, so it's still not enough to get up to 500. After day 3, though, haven't I gone to 662? So somewhere between day 2 and day 3, which is what we came up with, they heard the rumor. What are you going to answer, day 2 or day 3? Day 3, because day 2 not enough kids have heard it. But by the end of day 3, 500 kids will have heard the rumor. Really, it's 662. But by the end of day 3, what they're asking, the 500 kids have heard the rumor. So therefore, by the end of day 3, 500 students will have heard the rumor. Any issues, problems, or concerns?